Good example, students. So we are going to learn about thermochemical equation. So under this we are going to learn about the definition, the examples about thermochemical equation, and the types exothermic and endothermic reaction, and how they are represented. So these are the learning objectives we are going to cover today. Now, what is thermochemical equation? So thermochemical equation is a chemical equation that we are familiar with. So that contains reactant, and then we have the formation of products. So thermochemical equation will also provide us information about the amount of heat, released or absorbed. So once again, thermochemical equation is a chemical equation that provides the amount of heat released or heat absorbed. So heat released, we have a synonym for this. That means heat lost. And heat absorbed, the synonym you have already guessed. That is heat gained. So if a chemical equation gives you any sort of information about heat lost or heat gained, then that chemical equation is known as thermochemical equation. Now, example of heat released or heat absorbed. So let us look at heat released. Methane, CH4, when it burns in the presence of oxygen, it produces carbon dioxide, water, and also heat. So this diagram, the photo of the methane burning with a blue flame. So you have already guessed. So this flame produces heat, and that heat released is represented in the form of this number. So here you have a positive sign, then you have a number, and here you have a unit. So this unit stands for kilojoules. Kilojoules. And the joules is a unit to measure heat. So if you say this kind of chemical equation, so this is thermochemical equation. So once again, thermochemical equation will have chemical equation, and along with it the amount of heat absorbed or heat evolved will be also mentioned. So in this example, it is heat released or heat evolved, or we can also say heat lost. Now another example of the thermochemical equation is heat absorbed, or the synonym is heat gained. So here, when the nitrogen and the oxygen combines together to form nitrogen monoxide, the heat is absorbed. So the diagram here represents no heating, but what happens is the heat is absorbed within the container. So when the nitrogen and the oxygen is mixed together, the heat absorbed is represented with a negative sign. So this negative sign represents the heat is gained or heat is absorbed, whereas the positive sign that you have already noticed in the previous example shows the heat is lost. Now, the first example that we have already observed was methane burning in oxygen and producing heat. So, in this slide, we are going to relate exothermic reaction with the positive value of heat released. So this kind of reaction we call it exothermic reaction because heat is given out or heat is released. So any reaction where heat where heat is released is known as exothermic reaction. And the reaction in which heat is absorbed. The reaction in which heat is absorbed is known as endothermic reaction. So wherever you see a negative value of kilojoule, any amount of heat absorbed, we call it endothermic reaction. So what you have to understand from these two slides is when the heat is given out, the value is a positive sign. That is, heat is released. And if the sign, the amount of heat released, the amount of heat, if the heat is absorbed, the sign is negative. So if you see as the amount of heat absorbed, the value of the heat sign is negative, then we will call it endothermic reaction. If the amount of heat released sign is positive, we will call it exothermic reaction. So once again, let us try to relate endothermic reaction as heat absorbed, and the value of the sign of the heat will be negative. Exothermic reaction means heat is released outside and the sign of the heat release is positive sign. Now the last learning objective that we want to cover in this is how it is represented. So you might have already noticed that these two thermochemical equation looks little bit different towards the end. Rest are same. Methane burning in oxygen to produce carbon dioxide and water. But when it comes to the sign, in the first chemical equation it is positive. But when it comes to the second, you have an opposite sign and also you have a symbol here. So we call this the triangle shape as delta, or we also call it as change. Then the H symbol is called as enthalpy. So this will be a new term for you, enthalpy. But to understand it, you can also replace it with heat. So H will give you the amount of heat and the name is enthalpy, and the triangle sign that you see is the delta, or in short we call it delta H. We call it change in enthalpy. So once again, delta H will give you the change in enthalpy or change in heat. So from the previous example, you have already learned that the exothermic reaction can be represented with a positive sign, that is given here. And if you're going to use a delta sign to indicate the change in heat, just the sign changes to negative. So in this both the representation, both thermochemical equation presents exothermic reaction. So this is where we have to become a little bit more careful in understanding the amount of heat released could be positive, if not negative, based on the representation of delta H and without delta H. Then another type of thermochemical reaction that we have already learned was endothermic reaction. So the endothermic reaction, we have learned that it is the reaction in which heat is absorbed. So we have learned that when heat is absorbed, it is represented with a negative sign. Or if you're going to represent it in the form of delta H, change in enthalpy, the sign becomes positive. So whatever you have learned so far was endothermic reaction. Endothermic reaction, the value, the sign of the heat is represented with a negative sign. Is a negative sign. And for the exothermic reaction, the sign to represent the energy was positive. But when you are going to represent it in the form of delta H, for endothermic reaction, the sign changes to positive. And when you're going to represent the exothermic reaction in the form of delta H, the sign changes to negative. So this is the important point that you have to keep in mind. Without delta H, if you're going to represent endothermic reaction, the sign of the energy should be negative. With delta H, the sign becomes positive. And for exothermic reaction, without delta H representation of energy, the sign is positive. And with delta H, the sign becomes negative. So with this, we have covered the definition of thermochemical equation. So once again, to revise, the thermochemical equation is a chemical equation which provides you the information on the heat absorbed or heat released, heat gained or heat lost. Then we have looked at on the examples. The two examples: methane burning and producing heat, nitrogen and oxygen combining to absorb heat. And then we have also looked at the exothermic reaction and endothermic reaction. Exo means heat given out, endo means heat absorbed. Once again, endothermic reaction is the reaction in which heat is absorbed, and exothermic reaction is where heat is released or heat is given out. And the representation of thermochemical equation. So for exothermic reaction, the sign will be positive, but if you're going to represent it with delta H, the sign becomes negative. And for the endothermic reaction, the sign of the energy is, heat energy is negative, but if you're going to represent it with delta H, the sign becomes positive. So this is the crust, the heart of the lesson for today's class. So that's it.